Welcome back. We are going to be talking about compound inequalities, solving them, graphing them, and all that good stuff. So our objectives for this lesson, we're going to be solving inequalities containing the words and or, and also graphing these. So the first thing we have to start with is, what does compound mean? In math, compound means more than one. So we're going to be looking at more than one inequality kind of put together. So the first kind of a compound inequality, there's two of them. The first one is the one that includes the word and. When we're looking at compound inequalities, we want to think about rules. If we see the rule and we're talking about a rule, one example is maybe we want something to be x greater than 3. So if we were to graph this, these would be all numbers, including 3, that are greater than 3. So we can write this, and there's a couple ways we can write this, but we'll talk about that in a little bit. But maybe it's x is greater or equal to 3, and x is less than or equal to 7. So we have two inequalities together. They have to be, for it to work when we have the word and, it has to follow both rules. So where is it greater than 3 and less than 7? All right, it'd be these numbers in here, 4, 5, 6, and 7. Okay, from here to here. This spot where they overlap. Because let's say we pick a number like here, let's say the number 5. Is 5 greater than 3? Yes. Is 5 less than 7? Yes. So it has to apply to both rules. So if we pick the number like over here, like the number 1. Okay, like this number right here. Number 1. It is less than or equal to 7, but it is not greater than or equal to 3. So even though it works up here, it doesn't work here, which means it's not a solution. It's only where, and if you can see where they interact, where they intersect, where they overlap. That's what our equations, that's what our graphs will look like. So this can be written in two ways. One, we can include the word and. We can write this as x is greater than equal to 3, and we have to put this in here, x is less than or equal to 7. This is our first way that we can write this. It's applying this way and it's applying that way, and it's where they intersect. The other way we can write this, and this is how we usually write this, is just with one statement, without the and kind of there. We want to write this in numerical order. We want to write the smallest number followed by the largest number. Like a 3 and a 7. Not too hard. Now, we want to continue with less than signs or equal than signs and put the x in the middle. This is saying that x is greater than or equal to 3 and it's less than or equal to 7. And it lies between here. It's like this is the meat of the sandwich. It's kind of putting it all together. So we can write them in two different ways. Now graphing them, when we graph them, we want to graph the intersection. So I want you to write that down. With and problems, it's the intersection. It's where they overlap. Okay? It's where they overlap, the intersection. So if you see, every problem, one's going one way, the other one's going the other way. But it's where they intersect. Every graph will look like this 99% of the time if it's an and problem. We'll talk about some examples that might not look like this. but we'll do that a little bit later in another lesson. So let's look at some of these. I gave you some examples in your notes, and we're talking about ands. We want to think about how are we going to graph this if we're given these statements. So number one was -5 less than or equal to x, and then less than 10. Now when we're reading this, do you notice how both of these inequalities have to be going the same way? If they're going the opposite ways, you messed up and it's no longer true. They have to be going the same way. Most of the time you're going to see the smaller number here, the larger number here. So if we go to graph this, again, we know -5 is here, we know 10 is here. When we start by reading this, and it's in the box that I created, start with the variable and reading the inequality. So how is x related to -5? It's greater than or equal to. So greater than or equal to, remember it's a closed circle, and we're going to the left, or to the right, I'm sorry, because it's greater than. The other one is x less than 10. This one is an open circle and shading to the left. And now, where do they intersect? They intersect at the 5 with a closed circle. They intersect with an open circle at 10. And this will be our answer. As you can see, the answer is the meat of the sandwich. It's in the middle, right here. And that's how every single one of these will be. Number 2. This one's written a little bit different. We have x greater than 5 and x less than 25. So we start by graphing this. All right, I have 5 and 25. Here's 5, there's 25 on the graph. X greater than 5. Now these are written nice. You can see which way they're shaded. Open circle to the right. X less than 25, open circle to the left. Where do they intersect? Both of these will be open circles, and it's shading in the middle. There's our answer. So these are all answers between 5 and 25. And the third one. This should look familiar. We have 80 less than or equal to b less than 90. Hopefully you recognize this is how you achieve a grade of a B. Greater than or equal to 80% and less than 90. And if you hit 90, that's your A. So graphing this, we are at 80 and we're at 90. So we start with B is greater than or equal to 80. Closed circle to the right. Less than 90. Open circle to the left. And our answer is where they intercept. Closed circle on 80. Open circle on 90. And we shade in the middle. Now the other one, because there's two compound inequalities, are OR problems. So when we're thinking about this rule, it's not where they intersect. Think about this. If you're able to pass the class if you score a 60% or better on the test, or you come to class every single day. Either way, you pass the class. It doesn't matter which one you do as long as you do at least one of them. So how are these written? This is written just x is less than or equal to, say, 10. Then we write the word OR. Now, there's only one way to write these. It has to be an OR. Or x greater than or equal to, let's say, 21. Now, only one of the rules needs to be true on this. It could either be the first one or the second one. So let's see how this graphs out. We know we have 10 here and a 21 here on our number line. X less than or equal to 10. Closed circle. And we shade to the left. So all numbers less than 10. or greater than or equal to 21. Again, close circle, and we shade to the right. So comparing these, what do OR problems look like? It's going this way, or is the middle, it's going to the right. So OR problems are going left and right with these. Okay. So if we're looking at some of these, and that's how we would graph it too. So if we're looking at some of these, and I'm not going to do all of them, let's look at number 5. It says x is less than 0, or x is greater than or equal to 12. X less than, we have 0 and 12. Less than means just an open circle. We shade to the left. Greater than or equal to 12 goes to the right. So if it's an OR problem, it's going left and right. It's not shading in the middle. So where it says sum up, how will these graphs look 99% of the time? So there's a couple examples that we'll talk about later that might be different than this. So if it's an AND problem, most AND problems will be shading in the middle, like this. OR problems, it's going left and right with a gap in the middle. So in a standardized test, you might be able to eliminate some answers just by knowing the direction of what these are doing. Okay? The last thing is, how do we write these? So if you look on your paper, on the first one, on number 7, you have an open circle. My markers are dying, sorry. On the graph, you have an open circle going to the left from -6. And the other one is an open circle on 8 going to the right. So, is it shading in the middle or is it shading out? It's shading out, so therefore I know it's an OR problem. Automatically. There's a gap in the middle. So now I can write this. How is x related to -6? It's less than. How is x related to 8? Greater than. There's our answer. Number 8. This is an example. I think both numbers are closed circles. We're shading in the middle. So automatically I see that it's shaded in the middle. We have two endpoints of 1 and 7. I automatically know this is an AND problem. I can put, and I'll write this both ways, the more traditional way I'm going to put 1 and a 7, because both of these are closed circles, they are both less than or equal to's, and I put x in the middle. Here's the 1, here's the information of x, and there's the 7. It's written right in order. The other way we can write this is x greater than or equal to 1 and x less than or equal to 7. This one is the most common. You're going to see that probably from most mathematicians. So that's it on compound inequalities. Keep these notes, keep these handy, and I'm sure it will help. See you next time.